Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about liquid crystal. So I will start from introductions, then I will talk about what is liquid crystal, then further I will discuss about classification of liquid crystal, and then I will talk about the methods of characterization of liquid crystals and then applications of liquid crystals, and finally I will give you references from I have taken this lecture material. So let us start with the introductions. Intermediate state of mesophases and halfway between isotropic liquid and solid crystal. In solid crystal, basic unit display translational long range order with center of molecules located on crystal lattice and display orientational order. In isotropic liquid, basic unit do not represent or preset positional or orientational long range order. So in plastic crystal located on lattice but without any orientational order. In liquid crystal, basic unit display orientational order and even positional order along same directions. Liquid crystal phases represent intermediate stages called mesophases. Molecules that form mesophases called mesozyme. So friends, what is liquid crystals? Solid phase molecules with both orientation and positional orders and are held to each other strongly. Liquid phase molecules with no orientation and positional orders but are held together by weak intermolecular forces. Gas phase, no ordering, no intermolecular attraction. So friend, liquid crystal phase, a fluid phase in which a liquid crystal flows and will take the shapes of its container. It differs from liquid that here are still some orientational orders possessed by the molecules. So you can see the solid, you can see the arrangement of liquid crystal, and you see the liqueurs according to increasing temperature. Now friends, classifications. Liquid crystalline system: thermotropic, lyotropic, pneumatic, osmotic, and cholesteric, and then further cholesteric divided into intrinsic and extrinsic. Now thermotropic. What is meaning of thermotropic classifications? Phase transition depends on temperature. Temperature increases first. Liquid crystal phase is molecule A and layer-like arrangement and rotational motions of molecule. Further increased temperature lead to pneumatic phase. Molecules rapidly diffuse out of initial lattice structure and form layer-like arrangement. At highest temperature, materials become isotropic liquids where motion of electrons, motion of molecule changes again. At high temperature, material becomes isotropic liquid where motion of molecule changes again. Now friends, pneumatic phases, long range orientation order but no positional order. Before directions is known as director. Phase structure change in number way, example electric or magnetic field or treatment of surface of sample container. Now, friend, cholesteric chiral nematic liquid crystal. First liquid crystal through polarizing microscope is cholesterol benzoate. Example, cholesteric liquid crystal at 147 degrees Celsius and isotropic 186 degrees Celsius. It great potential uses following during delivery sensor, thermometer, fashions fabric that changes color with temperature, display devices. In cholesteric phase, there is orientation order and no positional order, but director is in helical order. So structure of this liquid crystal depends on pitch, which is distance over director, makes one complete turn. One pitch comprises several hundred nanometers. Pitch affected by flowing temperature, pressure, and electric and magnetic field. So look at the structure of chiral nematic phase. The director rotates about a horizontal axis. The distance for one full rotation is called a pitch. Now, types of cholesteric liquid crystals. Intrinsic cholesteric obtained by adding a chiral amphiphilic molecules to nematic lyotropic liquid crystals. Molecules take part in macromolecular structure as non-chiral amphiphile. Now friend, intrinsic cholesteric obtained by adding a chiral nanophilic molecules to nematic lyotropic. Depending on electrostatic characteristic of molecules, it can accommodate it either in inner or outer parts of micelles. So, smectic phase occurs at temperature below nematic or cholesteric phase. Not positional order are destroyed when crystal melt to form smectic LC, and these are useful in traumatic delivery. Different smectic distinguished on the basis of arrangement with varying temperature. Now friends, phase transitions occur with increasing temperature. Crystalline to smectic, carbon to smectic, A to nematic to isotropic, or crystalline to nematic to isotropic. So friends, you can see smectic phase, a director perpendicular to the plane. Smectic C phase, director makes an angles with the plane. So phase transition depends on temperature and concentrations. When two different substances are mixed together, the mixture can exhibit different phases, not only as the temperature is changed, but also as the concentration of one component of the mixture is varied. For example, a molecule that has ene group with different properties, one is hydrophobic and other is hydrophilic. Lyotropic liquid crystal differ from thermotropic liquid crystal formed by mesogen and by associate hydrate and solvate molecules. Hydration solvations are rod-shaped molecules result in different geometries such as cone and crystalline or cylinder. Cylindrical arrangement in layer results in laminar phase by altering polar nonpolar layer. You can see here laminar lyotropic and cubic lyotropic phase of amphiphilic molecules. Now discotic liquid crystals, disc-like molecule. The axis perpendicular to the molecules tend to orient along the specific directions. So Criteria for molecules being liquid crystal or crystalline. The molecules must be elongated in shapes. Length should be significantly greater than its width. Molecule must have same rigidity in its central regions. The end of the molecules are somewhat flexible. So, transmission electron microscope. Due to high magnification power, electron microscope micro inner structure of liquid crystal can be visualized. Aqueous sample do not survive high vacuum of electrons microscope without loss of water and their microstructure change. Therefore, a special technique of sample preparation is necessary, which is freeze fracture. Now, method of characteristics of liquid crystals. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.